Today we are going to learn, and here they are. Today we are going to learn we have two more topics remaining to learn, right? And the one that we're going to learn today is called differential equations. Differential equations. I mean, technically that's just... Really what we're doing is we're solving separable differential equations. That's technically the subject, not just differential equations. Let me give everybody a worksheet here. Now, there is a really, in my opinion, a really nice example that takes up 2/3 of the front page of this worksheet. So what we're going to do is we're going to go through that example. Can you hand this to the back row? Thanks, appreciate it. And you will not, well, you shouldn't need a calculator today. So let's look at this example and let's work through it together so that we can understand what is expected of you in solving a separable differential equation. Okay? It says solving a differential equation usually means finding a particular solution. That's usually what they'll say in the AP exam, is they'll say find the particular solution, which is basically the same thing as finding a specific antiderivative. Do you guys remember finding the specific antiderivative of a function? Do you remember being told, hey, f of x is a specific antiderivative of 2x minus 5, and f of 4 equals 9. Does anybody remember this? Do you okay. Do you remember what we had to do to find out what f of x is? No. Well, it's an antiderivative, right? So there's a symbol that you probably suspect we're going to use. Yeah, we're going to use. Well, it looked like you did the sum. What's that? Sigma? Yeah, no, but it's sister. Okay? So we have to do the antiderivative of what? Of this, 2x minus 5, right? So we know that f of x is a specific antiderivative of 2x minus 5, and so we have to put a dx on there. What is the antiderivative of 2x minus 5? Just think about it. Blow off the dust. Let the wheels turn. X squared minus 5x plus c. And do you remember that finding a specific antiderivative, one of the main tasks in finding a specific antiderivative is doing what? Well, what are we doing with plus c? Solving for c, right? So if we know that f of x is equal to this thing here, and we know that when x is 4, the answer is 9, how can I solve for c? That's right, plug in 4. This is called, I want you to think of this, the phrase is going to be the initial condition. The initial condition. So we're going to plug in the initial condition. If we plug the initial condition in, we know that if we plug a 4 in for x, so 4 squared minus 5 times 4 plus c, what must this equal? 9. This must equal 9. And 4 squared is 16. And 5 times 4 is 20. Plus c equals 9. 16 minus 20, negative 4, plus c equals 9. Add 4 to both sides, and c is equal to 13. Did I do that? I know I did it fast, but I think you're okay. So now, what is f of x equal to? What is the function f of x equal to? Well, no, it's an antiderivative of 2x. There you go, x squared minus 5x plus c, and what is c? 13 plus 13. So f of x is the specific function x squared minus 5x plus 13. And what is its derivative? 2x minus 5, which was in the question. Do you guys kind of remember this? All right. So what we are about to do, solving differential equations, is basically the same thing as this, except we're not only dealing with an antiderivative of x, we're also going to include an antiderivative of y. Okay? So let me show you what was basically done here. If f of x is a specific antiderivative of 2x minus 5, then 2x minus 5 is, would you agree that 2x minus 5 is the derivative of f of x? And the derivative would be dy dx, right? So dy dx is equal to 2x minus 5. All right, ready? I need you to see this. Ready? Here's what we're going to do. Algebraically, we multiply both sides by dx. Do you remember doing that before? Right, when we did u substitution? So if we multiply both sides by dx, I got to multiply this side by dx. But I want to be careful here, because if I put a dx here, this is technically incorrect. What do I have to put? What do I need over here to make this algebraically correct? Am I only multiplying dx by minus 5? No. So I need what? Parentheses. That's what I need. We'll get to the symbol in just a minute. I need to put parentheses around the 2x minus 5, right? Because this is dx times the whole thing. And what I now have is dy equals 2x minus 5 dx. And I think I might have forgotten to put the parentheses in this example. No, I didn't. It didn't need parentheses. Okay, now, when you see an expression with a dx after it, it is asking you to do what? Say again? Not the derivative, close. The antiderivative this is asking you to put something in front of this. What is it asking you to put in front of this? An integral symbol, right? So we got to put an integral symbol here, right? Now over here, do you see this dy? You know what's in front of the dy? What's in front of any variable when there's nothing in front of it? A 1. There's a 1 over here. And what is this asking you to put in front of it? An integral symbol. So technically what we're doing here is, see, we already knew to do this, right? And we already identified that the antiderivative of 2x minus 5 is x squared minus 5x plus c, right? So we're done there. What is the antiderivative of 1 with respect to y? Okay, well, let me ask you this. Let's take a break for a second. I'm going to a different color. What is the antiderivative of 4 with respect to x? It's 4x, right? Plus c, but we'll ignore the c for now. Okay? So what would the antiderivative of 1 be with respect to y? It would just be y, correct? So y equals, which is what we basically had over here, but instead of y equals, we came up with f of x equals. Right? Do we feel okay with this? Okay. So now let's look at our example on the worksheet. Our example on the worksheet says, find the particular solution, y equals f of x, to the differential equation dy dx equals negative x over y. What is the particular solution to negative x over y? How is this different than the one we just did? Well, that's true. That's different. What else? There's another major difference here. You're right, because of what we just did. You know that this is a circle, right? That's good. No, that was good, Trent. You know that this is the rate of change of a circle because we just did the slope field, right? Okay. But what else is different about this from all the other antiderivatives? There's an x and a y. We have not yet done any antiderivatives that include an x and a y, right? Okay, what's that?
I was hoping I'd never see one.
Yeah, sorry about that. Actually, given that you said that, here, let me make your nightmare real.
Okay, I'm prepared.
And I'll show you. Actually, you can just look down the page. Just look down the page. Look at all these nice, beautiful differential equations. I mean, 15x to the fourth over 2y is tame compared to 3x squared plus 4x minus 7 over 6y. But that's still nothing, flip over, compared to secant squared of x over 3y squared. Yeah. And some of them are way worse from the AP exam. They love to have a lot of fun with these differential equations on the AP exam. Look up there on the overhead. You'll like this one. There we go. How's that one? There's a differential equation. 3x squared over e to the 2y. And then this one's an easy one, actually. 3 minus x over y. That's really easy. Very, very easy, that one. In fact, maybe we can do that one later. Okay? But here's the thing is I want to take away your fear of this. It's actually really easy. In fact, on the AP exam, these kinds of questions usually will grant you 4 or 5 points out of 9, which is pretty nice. And most of those points are easy to get. The last point sometimes takes a little bit of time, but the first few points are usually pretty easy. So here, let's go through the steps. Did I list the steps on the paper? Where's my key? Oh yeah, there it is. Okay. All right. Step 1, and you will get 1 point for doing this on the AP exam. The first step is always to separate the variables. What that means is this. Everything with a y goes on the left. Everything with an x goes on the right. You are separating the variables. Like a shepherd separates the sheep from the goats. Okay? So if you have x's over here and you still have a y over here, you're not done. You have not separated the variables. Okay? So look, how can I get that y over on the other side algebraically? Yeah, just multiply by y. So if I multiply by y here, I also have to multiply by y on this side, right? That's going to cancel the y over here, and now I have the y over there. Now what? I need to multiply both sides by dx because I have an x over here and I need it on the other side. So I'm going to multiply by dx over here, and I'm going to multiply by dx over here. Over here, it's going to cancel the dx. And now I can carry everything down. What is left over here? What remains? Y. Y dy equals negative x dx. There we go. We have separated the variables. That will earn us on the AP exam. Typically, that would earn you 1 whole point. So if you're trying to get 9 points out of this question and you're looking at it and you're like, oh man, that looks like a tough question. Maybe I'll just separate the variables and get 1 point for now and see where it goes from there. All right, now, what is this dy asking you to do? Yeah, an integral. So what do I have to put in front of the y here? I need to put an integral symbol there. And what about this dx? What's it asking for? An integral. So I'm going to put an integral here. Let me put this in parentheses just for fun because it's got a negative. So now, step 2 is integrate both sides. And if you successfully integrate both sides, you will probably get another point. What is the antiderivative of y? Think about it for a minute. What's the antiderivative? What's the antiderivative of x? I mean, it's just not just y squared. 1/2. Oh, is that what you said?
Yeah.
I'm sorry. Yeah, because remember, we have to power up, add 1 to the power, and then multiply by the reciprocal, right? Okay, so 1/2 y squared is the antiderivative. Now, somebody asked me the question. Somebody's thinking it. I did not do something here. What did I not do? No, well, that goes away when we... Why did I not put a plus c? Okay, well, let me explain. The plus c doesn't belong to the term. The plus c belongs to the whole equation. So you only need 1 plus c on the whole equation. So we put it with the x, not with the y. Does that make sense? Okay, all right. So now, I'm done over here. Let's move over here. What's the antiderivative of negative x?
Negative 1/2 x squared.
Negative 1/2 x squared. Now, plus c. We need a plus c. There we go. So this, we have now successfully identified the antiderivative of both sides. This would probably earn us 1 point on the AP exam. Now, sometimes on the AP exam, they will give you 1 point for both of these steps. So it is important to try and do both of them if you're thinking I'm not going to be able to finish the whole thing, you can still get some points just by doing part of the steps. Okay? So that's step 2. Step 1 is separate the variable. Step 1 is separate the variables. Step 2 is integrate both sides. Step 3. I'm not looking at the paper, but I think I remember that step 3 is usually use the initial condition or plug in the initial condition, right? What is the initial condition? What were we told in this problem? It says, what's the particular solution with initial condition what? F of 7 equals 6. That means that when x is 7, f of x equals 6. There we go. So we've got an x value and a y value. And so what are we going to do with this x value and y value? We're just going to plug it in for x and y here, right? So we're going to have 1/2 of 6, is it 6? Yeah, 6. And then squared equals negative 1/2 of 7 squared plus c. We have just used the initial condition. Sometimes they will give you 1 point just for knowing that you need to plug in. Now this, I don't know if they do this anymore. I think they used to do this. I think they took a point away in these problems. And they may expect you to don't just plug the numbers in, but you also have to solve for c. Okay? So now the next thing is we got to solve for c. That would be step 4. Okay? So what is this going to become right here? 18 equals, what's this going to become? What's 7 squared? 49. Half of 49. We could just say 49 over 2. And it's negative. That's right. And you know what? Since we have an over 2 over here, I'm going to make this 18, 36 over 2, because I know that I'm going to have to add or subtract fractions. So I'm going to leave this as 36 over 2. Plus c. That's right. All right. Last step. Add 49 over 2. Both sides. It'll cancel on this side. And we'll have c equals 85 over 2. Is that what I have on the paper? I hope I'm not messing up. Okay, good. Because I mess up sometimes. Okay. And now what we can do is we can now plug that back into what we had in step 2. We can now plug that in 4c. And so now we'll have 1/2 y squared equals negative 1/2 x squared plus 85 over 2. If you get this far, they will give you a 4th point or a 3rd point, depending on whether they're giving out. If this is a 5-point problem, you've got 4 points so far. If it's a 4-point problem, you've got 3 points so far. The last point is generally earned by solving for y. So you have to do algebra here and find out what y is equal to. Okay? So what do you think? What can we do here to clean it up a little bit? Yeah, let's get rid of the half. How can we get rid of all these over 2's that we have? We go right through and multiply by 2. If we multiply this by 2, we just get y squared. Multiply this by 2, we get negative x squared. Multiply this by 2, we get plus 85. Right? Okay, now, what do we do next? We need to do the square root of both sides, right? Square root here and square root here. Now, don't get freaked out by this. Somebody is going to think, but Mr. Ryan, you can't take the square root of a negative. Yes, you can if that negative is on a variable. Okay, let me show you what I mean. X cannot take on a value larger than the square root of 85. Here, okay, watch this. If x is the square root of 85, what is the square root of 85 squared? 85. So now it would be negative 85. And what's negative 85 plus 85? 0. And can we get the square root of 0? Yes, right? We can. Yeah, which is 0, correct? So yes, it's okay to take the square root and still have a negative here. Now, if this number is larger than the square root of 85, for example, if this number is 10, 10 is larger than the square root of 85. 10 squared is 100. Negative 100 plus 85 is negative 15, and then we can't get the square root of negative 15, and it's now inappropriate. So 10 is outside of the domain. The domain here is going to run between negative square root of 85 and positive square root of 85. Okay, so now, the square root of y squared is y, correct? Now, there's something you may or may not remember about taking square roots. Do you remember that when you take a square root, on one of the two sides, you have to put a plus or minus? Do you remember that? If I had y squared equals 16, and I do the square root here and the square root here, what is y equal to? Is y just equal to 4? No, it's equal to plus or minus 4, right? So if y was negative 4 squared would also be 16. Are we good? Okay, so we have to put a plus or minus in front of this square root. So y is equal to plus or minus the square root of x squared plus 85. All right. Now, the last step here, in order to get your full credit, doesn't the question say y equals f of x? All right, so we got to turn our y into f of x. But here's the thing. Our answer is not plus or minus the square root of x squared plus 85. It's only one of them. It's either the positive version of the square root of x squared plus 85, or it's the negative version of the square root of x squared plus 85. Which one is it? It's the positive version. How do you know it's the positive version? There's a good... You're right. Guys, look at the question. There's too many people not looking up here. Look, you need to be looking at... Here's where you need to be looking. That's where you need to be looking. Because the answer is positive 6, not negative 6. If the answer was negative 6, then it would be the negative version of it. But in this case, the answer is positive 6. Therefore, the answer is the positive version. And did I get this right? Is this what I have as the answer on? Oh, thank you. This is negative. I'm so sorry. Thank you. Negative x squared plus 85. So the final answer, f of x, is equal to, and of course we can plug in our initial condition to make sure. If I plug 7 in, 7 squared is 49, negative 49 plus 85 is 36, and the square root of 36 is the positive version of the square root of 36 is 6. Are we good? And we just earned our 5th point, and we just got 5 points on this differential equation. Or we got 4 points on it if they only gave us 4 points. We won't know while we're taking the AP exam. Of course, I'm not going to be taking the AP exam.